In this particular presentation we are going to see about the design of the flat belt drives. So coming to the classification of the power transmission system, the flexible drives are rigid drives. The rigid drives are gate drives. Coming to the flexible drives, that's what we are going to discuss in this particular presentation. Flexible drives may be belt drives, rope drives, chain drives. Again, belt drives are classified into flat belt drives and V belt drives. So what in flexible drives, these flexible drives, because it is called flexible drives because it absorbs the shocks and vibration, cheaper compared to gate drives, used for longer distances, tolerance on the center distance is not critical, occupy more space, velocity ratio is not constant. These are the two disadvantages are shown in the red color. Rigid drives do not absorb shocks and vibrations. This is one of the limitation. Costlier compared to belt drives. This is also limitation. The advantage is used for the short distances. Tolerance of center distance is critical. Mm, Occupy less space. Velocity ratio is constant. These are the two advantages. Coming to the belt drives. So belt is a flexible machine element that transmit power from one shaft to other shaft. The amount of power transmission depends upon the velocity of the belt, tension in the belts and arc of contact. The upper side is called slack side, the lower side is called tight side. This is the driver pulley and let's called driven pulley. So coming to the types of the belt, it may be light drives if it transmit power less than 5 kilowatts, medium drives 5 to 20 kilowatts, heavy drives so which transmits more than 22 kilowatts, and velocity also given 10 meter per second, 10 to 22 and above 22. And coming to the next types of belt drives, these are manufactured either with the leather belts or cotton and fabric material, rubber belts or balata belts. So flat belts and V belts. Flat belts are rectangular cross section, whereas the V belts are trapezoidal cross section. Your flat belts are used for longer distance, V belts are used for shorter distance. Power transmission is lower in the case of the flat belts, higher in the case of the V belt. Velocity ratio we can maintain is lower up to 4:1. This is up to the reduction ratio. We go for 7:1. Efficient, more efficient flat belts, less efficient V belts. So flat belts are cheaper than V belts, and that means V belts are costlier than flat belts. So it may be belt drives. There are open belt drives or cross belt drives. In both the cases, shafts are arranged parallel to each other. But in the open belts, the pulleys are rotating in the same direction. In the cross belt, rotating in the opposite direction. So these diagrams clearly shows the open belt drive and closed belt drives. And types of belt drives: stepped pulley drive, it is used for changing the speed of the driven shaft while the main shaft runs at a constant speed. And desirable properties of the belt should have high coefficient of friction, high tensile strength, high wear resistance, high flexibility and low rigidity. So velocity ratio of the belt drive is given as, so driving pulley speed by driven pulley speed and is equal to, so driven pulley speed by driving pulley speeds. This should always greater than 1 when this is the formula is when there is no slip is not considered in this. If we slip, we consider the slip here and thickness, this formula becomes n2 by n1 equal to d1 plus d by d2 by 3 into 1 minus s by 100, where s is equal to s1 plus s2. That is the tip both slip both in the tight side and slack side. This is a condition for the maximum power transmission. V is equal to under root of T max by 3m. And coming to the design of open belt drive, assume the suitable belt velocity, calculate the diameter of the driving and driven pulley, small d and capital D. Next we have to calculate the length of the belt. Next we have to calculate the load correction factor, that is service factor and arc of contact factor. Next we have to calculate the design power. Design power equal to given power or rated power multiplied by the service factor and angle of contact factor. Next we have to calculate the corrected power rating of the belt. So next we have to calculate the width of the belt assuming the suitable number of plies. Suitable number of plies we have to assume based on the given conditions of the problem. These formulas are given in the data book. So let us see one problem of a leather belt, open belt drive. Nothing is mentioned in the problem, just we have to assume the open belt drive. Here we have to calculate the diameter of the pulleys, small d and capital D, length and width of the belt and the belt tensions. So step 1, diameter of the pulleys we have to calculate. So here we calculated small d and capital D. In the next case we have calculated the belt length, that we got 4981.446 mm, 46 mm. In the third step we calculated the belt dimensions and the belt tensions. So here we got answer 1428 and 690 Newton 92 Newtons respectively. So this is about the design of the belt drives.